All right, in this video, we're going to find terminal points on the unit circle, and we're going to use this idea of reference angles. So we're going to simplify more complicated angles like this one so that they bring us back to what we already know about the unit circle. Okay, with this goal in mind is we really want to be able to understand how to deal with complicated angles. So what we need is this idea of what's called a reference number. And it's just basically the shortest distance between whatever angle we have, the t, and the x-axis, okay? And we denote that with a t with a bar over it. Okay, so let me just start with, for example, well, in quadrant 1, it's not all that exciting. If we've got some positive t, pi over 4, the shortest distance between where we are at pi over 4 and the x-axis, well, they're the exact same thing. So in this case, t is equal to the reference angle. Okay, but let me get into one that's a little bit more, tiny bit more interesting. Okay, so let's say if we have our t is getting us to quadrant 2. Well, now, okay, there we are at 3 pi over 4. But here, the shortest distance between where we are and the x-axis, that's always where we're trying to find that shortest distance between the x-axis. That is pi over 4. Okay, so in quadrant 2, what you do is you take pi and subtract your angle. So we take pi minus 3 pi over 4. And this could be, you just always want to get a common denominator there. All right. So now I don't need to do every single one of these, but you'll kind of see, here we are, shortest distance here. We've gotten to 5 pi over 4. Shortest distance here, again, is pi over 4. And the way you'll get there is to take your angle, 5 pi over 4, and subtract pi. And then in quadrant 4, if I've come all the way over to 7 pi over 4, 7 pi over 4, now my reference angle needs to be, you take 2 pi and then subtract your angle, 7 pi over 4. So 2 pi would be 8 pi over 4 over 4. So that would give us that reference, which is pi over 4. Okay, so now let's look at what happens when we have our angle is negative. And we're still looking for that reference angle, but we've got negative angle. So I'm going to give you some examples and let you draw them in and just see if you could come up with a general formula for the reference angle. Okay, so let me give you some examples. Okay, so go ahead and draw those examples in. We've got negative angles, right? So we need to be coming in the clockwise direction. Okay, and your goal is to try and come up with a general formula for what would the reference number be there. All right, so let's see, we've got negative 3 pi over 4. Negative 5 pi over 4. And negative 7 pi over 4. Okay, so now, okay. All right, so t is the opposite of our reference number because it's a positive pi over 4. So you just take the opposite of your angle, and that would be in quadrant 4. Good, and now here, well, they're all just pi over 4, those reference numbers. Sorry, my examples aren't terribly exciting yet. Okay, so, but in quadrant 1, 2, 3, what we need is we're going to take our pi, and we take pi and we add our reference number, so we get pi plus a negative 3 pi over 4. And we can think of pi as 4 pi over 4 and then minus 3 pi over 4, and that would give us the correct reference number there. All right, and in quadrant 2, let's see, quadrant 2, what we need to do is take the opposite of our angle and then subtract pi. So take the opposite of our angle and then subtract pi. So we'd get 5 pi over 4 minus 4 pi over 4, and that gives us the correct reference angle. And then this one in quadrant 1 is we take 2 pi and we add that angle. So we would take 2 pi and add a negative 7 pi over 4, and 8 pi over 4 plus a negative 7 pi over 4. That would give us the correct reference number of pi over 4. Oops, that should be over 4. Okay, so general formulas here in quadrant 4. You take the reference number as the opposite of t. In quadrant 2, it's pi plus t. In quadrant, that's quadrant 3. In quadrant 2, opposite of t minus pi. And quadrant 1, it is 2 pi plus t. Okay, so there you go. General formula of how to figure out your reference numbers. Okay, we're going to find the reference number for an angle of, or for a t of 4 pi over 3. It's positive, so I'm coming in the counterclockwise direction, counting by thirds. Okay, so we're at, here's pi, and counting by thirds. We've got 3 pi over 3, keep going, one more third, so here we are. So t is 4 pi over 3. Okay, but the reference number, that is just that little section between where we are, the shortest distance between that and the x-axis. So t bar, that reference number is pi over 3. Good. All right, let's try this next one. Here we're going negative, so we need to be going clockwise. Okay, and we've gone 1, 2, 3, pi over 4. All right, so shortest distance between where we are, 3 pi over 4, and the x-axis here, that reference number is pi over 4. And now if I have 3.5 for my t, it's positive, so I'm going counterclockwise. Okay, and here is pi, and that's approximated at 3.14. Here, this one is 3 pi over 2, and you can just use your calculator. 3 times 3.14, divide all that by 2. Let's see, that's approximately 4.71. All right, so 3.5, that is about here. Okay, and then the reference number would be just that little section right there. And in quadrant 1, 2, 3, what we do to find the reference number is we take our angle and we subtract pi. So that means we would take 3.5 and subtract pi. And we could approximate it, but we're being asked to find the exact value in these problems. Great. Okay, so there's our reference numbers. And now we're going to actually use our reference numbers because our goal is to figure out terminal points, so the x and the y coordinates at any given any t. All right, so 4 pi over 3. Let's see. Counting in thirds. So here's pi. That would be 3 pi over 3. So 1, 2, there's 3. Keep going, one more. So we have gotten to positive 4 pi over 3, and our reference number is just that little section right in there, which is pi over 3. Okay, and then that, so the reference number is helpful because that's related to that positive t of positive pi over 3 is just since we're in quadrant 3, we need the x and the y values to be negative. So for pi over 3, that is the terminal points there are 1/2 root 3 over 2 for my x and my y, and here they're going to be the same. It's just that we need negative signs on my x and my y to get us into quadrant 3. There we go. So there's our terminal point. Okay, let's look at this next one. So negative 3 pi over 4. Okay, counting, first of all, I'm going clockwise because it's negative, and so counting in fourths. This is right, this is pi, counting in fourths. We haven't quite gotten there, so we're right here at negative 3 pi over 4, and then the reference number there is pi over 4, but we're in quadrant 3, and so we need the x and the y to be negative, and that's related to that reference number here at pi over 4 and root 2 over 2. I love these fourths because the x and the y are the same. Okay, so quadrant 3, just negative x and y values. Okay, let's try another one. So 13 pi over 6. Okay, we're counting in sixths. It's positive, so I'm going counterclockwise. If I went here, this is pi, counting in 6, it'd be 6 pi over 6. Here, this is 2 pi, counting in 6, that's the same as 12 pi over 6. So if you don't always want to have to draw this out, what you can do is just simplify that. You're going all the way around, so you can just subtract that 12 pi over 6, and that gets us to our point, which is the same actually as our reference angle because we're in quadrant 1, and so here we are at pi over 6, and the reference or the terminal point there is at root 3 over 2 and 1/2. Okay, and I'm going to make this next one a little bit bigger. Okay, so here I'm going in the negative direction. I'm going clockwise. Okay, and I'm counting in thirds. This would be pi, which is 3 pi over 3. This would be 6 pi over 3. But if I go around a couple times, there's 6 pi over 3. But if I keep going, this is the same thing as 12 pi over 3. Keep going again. 1, 12, 13, 14, 15. There would be 15, 16, 17, 18. 18 pi over 3. Okay, so if I'm going to deal with this t of negative 20 pi over 3, I can simplify that by adding 2 pi, but I know I'm going around 3 full times, so I'm going to actually add 18 pi over 3, and that would get us negative 2 pi over 3. So that's just a little bit easier to actually figure out. So here's gotten us to 18, negative 18 pi over 3, and then keep going another 19, and there would be negative 20 pi over 3. Okay, so reference angle. I'm going to erase that. Okay, reference angle. That is this section right in here, and that is pi over 3. And that one we just did as well. So that's related to a t of a positive pi over 3, but we're in quadrant 3, 1, 2, 3. So I know my x and my y need to be negative, and that gets us to a terminal point of 1/2 and root 3 over 2. Okay. All right, and we just met our goal, which is to find the terminal points, so the x and the y coordinates of any given any t. So we are done.